The first fundamental theorem of calculus, are the main thing that ever happened about it was these were like the limits of integration that Leibniz was keeping up with. And so that means like, and the ones I did for you at first, like if you're going from like 0 to 3. So you had to have somewhere to write where he was going from. And for now, I'm gonna call this like a derivative. And they were busy adding up length sums widths from wherever to wherever. And they knew they were getting displacement. But what was so fundamental was they were going through all of those rectangles that we learned and trapezoids and so on and so forth until Leibniz and Newton, it was credited to them, that they realized, whoa, hang on. Could we possibly just take the antiderivative and get it right when it's possible? So the first fundamental theorem of calculus is you could actually work these long problems finding area and volume and displacement by just taking the antiderivative from A to B. And that'll give you f of B minus f of A. Now today, that statement on this first slide is actually going to become an algebra problem. I'll come back to it. But that's the first fundamental called FTC1, if we're just writing it quickly. Fundamental theorem of calculus. That's the first fundamental theorem of calculus. And I don't know if I've made my point big enough yet, and how incredibly fundamental that is. It ties together differential and integral calculus. It's usually written like this. The integral from A to B of f of x dx or f of t dt equals f of x for f of t from A to B, because once they figured it out, I'm not really sure what notations they had in place back then, but they, if you have a little f, so it's classic in calculus, so if you're going backwards to find the antiderivative, you can't don't have anything to unmark, so you could do a capital F. I actually like to write it like this. It really drops the point home. So what's so fundamental about that is that when you can find the antiderivative, when you're able to find the antiderivative, let me start again. I have such a hard time talking to me. When you've got to work an integral, it was and always will be just a summation tool that keeps a running total. It was not an antiderivative and it does not find area and volume unless it's used correctly, okay? An integral symbol just is a running total. So if you run a running total, whether it's positives and negatives or whatever, that's what you use. You can also use it to find area and volume if you know what you're doing. You've got to orchestrate it correctly, which we'll continue to talk about for a long time. But it's always a summation tool. So when you're able to take the antiderivative, that was the eureka moment. You could actually work it that way by finding the antiderivative. If you can't find the antiderivative of it, you go back to approximations or see if it's geometric or punch it in our calculator. Which was our calculator doing? Adding up an infinite amount of rectangles. Okay? Alright, so that's the first fundamental theorem of calculus. There's a second one coming later today. I'm first going to work number 23, a way that may make you kind of angry at yourself, I hope, okay? 23, maybe it's not 20. Yeah, 23 is 0 to 5. Of the absolute value of 2x minus 5 dx. I told Caitlin this morning that every time I get to this problem this time of year, I'm just like, what am I doing wrong? It just points the finger back at me. Because I've talked so much about absolute value, and even if I was your Algebra 2 teacher, which I was for some of you, I talked about absolute value a lot, and I still just, I think if we don't see them enough, I hope it's not that I'm just not an efficient teacher. I hope it's that you don't run into them a lot, but you should know what to do with absolute value. Girls, if you run into something on a test that you've forgotten how to work, or you think, did she ever show me how to work this? Scrap it. If if I fill in 0, starting at the beginning, I get 5. By the way, you should know from your algebra that this is a variation of this parent graph, absolute value of x. Absolute value doesn't always make a v. Okay? Absolute value doesn't always even make 2 pieces. You just gotta really know what's going on. The 2 from your algebra will stretch it, and a combination of these numbers right here will move it to the right. Okay? With my students in Algebra 2, I always taught them to find their most important number, not their critical number. But their most important number, what makes that 0, is 5 halves, or 2 1/2. Because if you go from 0 to 5, if you fill in 5, you also get 5 if you check me on that, okay? If you fill in 1, you get 1. No. If you fill in 2, you get 1. And if you fill in 4 or 3, you also get 1. Let's pause for a minute and see what's just happening. I just got 1 2 times. If I fill in 2, how did I get 1?
-1.
It was negative, and the absolute value made me change my sign, right? But on this side of 2 1/2, when I filled in 3, which is not quite 3, sorry. When I filled in 3, I got 6 minus 5. Did the absolute value do anything? It did not. 2 1/2 gives me 0, and it looked like this. So couldn't you have found the integral from 0 to 5? Don't forget what I've taught you. You might have to use that, okay? You know what it is. It keeps a running total. Why will it find area this time is because the entire thing is what? Positive, okay? Now, let's move on though how I really want you to work this. Absolute value from the very first moment you ever saw it. If you had to work this in pre-algebra, your teacher would say, well, let's look at 2x minus 5 equals a, and the opposite of 2x minus 5 equals a. They weren't telling you we're doing a piecewise function yet, but I wish they had, because life would be a lot easier. If I asked you to take the derivative of this, so pause for a minute before I go on. In algebra, they didn't teach you what to do with absolute value. They said, let's break it up into pieces. Okay? That never stops. None of us know how to work with absolute value. You always have to break it into pieces. Okay? If I want you to take the derivative of that, y'all remember that we would do a piecewise function? It would be 2x minus 5 when x is greater than or equal to 5 halves. What would it be if x is less than 5 halves? Negative 2x plus 5, is that what some of you were saying?
Yeah.
All right, and you just saw the picture. You had a slope of negative 2 before 5 halves, and a slope of positive 2 after 5 halves. Before 5 halves, you have a negative underneath there. And what's absolute value doing under a negative is totally changing all the signs. What does absolute do to a positive? Absolutely nothing. So do you see you want to find out your breaking point, what makes it 0? Okay, and then you can take the derivative. Same thing for the integral. So you will see these on tests. So make sure that when you run into a piecewise function, that you handle it, an absolute value you handle as a piecewise function. Now in all of my talking, I've set that equal to 0, and I found my most important number where it breaks apart. So I'm going to integrate it from 0 to 5 halves. And then I'm going to continue on from 5 halves to 5. If you didn't do that. Does that make sense? All right, from 0 to 5 halves, the part in here is negative. And so I've got to totally change all the signs. Take its complete opposite, which will ensure you get the right numbers. After 5 halves, like 3 and 4, this is positive, so what are the bars doing? Absolutely nothing. All right, please let that, just look at it for a minute when you encounter it, which is not very often. That's what you have to do with absolute value. But don't hesitate to draw a picture. how often am I drawing pictures? Like a lot, okay? So don't hesitate to maybe work it out a different way because you know what an integral really is. I'm glad you felt stuck on it because you guys, I don't know how to take that antiderivative. But neither do you know how to take the derivative unless you make piecewise functions. Okay? Can y'all finish it from there? Okay. You do the first part and then add the second part. Alright? While I'm on that, I think this is kind of what Grace was about to ask me. There's all these little like notations that I take for granted that you know or have seen, but I want to make sure. If I have the integral from a to b of f of x dx plus the integral from b to c of f of x dx, does anybody know what that gives me? A to C. As long as these numbers match up, it gives you the integral from A to C of f of x dx. Okay? Don't forget what happens if you, like, if I'd had this, integral from A to B of f of x dx minus the integral from C to B of f of x dx. And they don't give you any other information, just some numbers of what the integrals are. And you can't work it out because you don't know what f of x is. Then what could you do there to pull that off? You can switch your limits of integration, Celine. Very good. All right, so we're going to go from A to B of f of x dx. And then we're going to switch our limits of integration from C to B. We're going to make it B to C. And if Celine switches her limits of integration, what does it do to her sign? Changes the sign. And then she has from A to C. Okay? So you might have to do something like that. There was something else I was going to do with this absolute value problem. Oh, by the way, absolute value of a line, and some of my Algebra 2 students that I had might remember that with absolute value of the picture, and I've spoken about that in here before, okay? If I have a line like that, the reason absolute value makes a V is it doesn't do anything to this part, and it flips that part up. Do y'all see what I mean, where your piecewise function comes from? Okay. But what if I have the absolute value of x squared minus 9 dx from negative 4 to 4? What are my most important numbers? I have two important numbers, don't I? Two things that make it 0, Carlos. I have 3 and negative 3. So I'm going to have to integrate this from negative 4 to negative 3. Then I'm going to have to integrate it from negative 3 to 3. And then I'm going to have to integrate it from 3 to 4. But this isn't linear anyway, it's quadratic. All right, let's look at a picture. What do you know about x squared minus 9? X squared minus 9 would move it down, right? So these are the numbers that Carla quoted as negative 3 and 3, okay? Before negative 3, are the absolute value bars doing anything? That's x squared minus 9. After 3, from 3 to 4, it's positive. And what's it going to do between negative 3 and 3? What's the absolute value of this going to do? It's going to leave this alone, but it's going to flip that up and make a W or something, okay? So I've got to take its complete opposite, which is really aggravating when you have 3 integrals to do. You couldn't pull that one off geometrically. You have to be able to do it this way. So absolute value doesn't always make a V. Absolute value of x always makes a V, and variations of that. Does absolute value of x squares of quadratics always make a W? gonna just integrate x squared. Except for 0, which is a negative, so I'm not really worried about it. It's the absolute value doing anything to that x squared. So as long as you have something plus, it moves it up. The minus is gonna pull it down. I want y'all to visually think about that. It's gonna go under the 2 intercepts. So y'all see the fluency that, while you're sitting in this room, we really talked about each one of you, and how you have this ability to have a fluency in mathematics. See the big picture literally, see the picture. All right, so that was probably a lot on number 23. My suggestion is you break it up, and if it's linear, it'll make a V, unless, girls, it's a vertical or a horizontal line, okay? But if it's a horizontal line, it would be like y equals 4, something like that. Okay, so now I'm gonna go to 62, the blood flow. I'm gonna look at some So 62, I feel about 62 like I felt about the sprinkler problem. And I still assign it every year. And then when people first ask me about it in the morning, before homework's due, and I'm sitting there looking at it going, oh, I hate this problem. It's pretty vague. They're going to have to do a better job of explaining what's variable and what's constant. I'm not sure that I can find what I'm looking for, but I'm just going to look for a minute. Sorry. That was a cough and a sneeze at the same time.
Sounds so real. So like a week or 2 ago, she was like, and then she was like, yeah.
The little bit that I know about this, I know more about sprinklers than I do blood flow. Even though they didn't really tell us what kind of sprinkler we had to just assume in the last one that it was a back and forth instead of a one. But do y'all see these R's here?
Yeah. The thing that they did to Google Images is like they shifted it to the right and then up the side. Yeah.
Okay, girls.
And it's really hard to zoom in. Oh yeah.
Do y'all see this formula is sort of similar to what we had in 62 with the R1 minus R2? And that's also similar. Remember they said there was some constant of proportionality in there?
Yes.
And I told some people this morning that were in the math center, back when I used to have when I saw students every day and had like career projects that were super fun, a cardiologist came and talked to my class one time that he would use, his point was that he also was a math major, and so it made him, he said, a better cardiac surgeon or whatever it was than he was. So many people came in from all walks of life that said, I'm a math minor, or a math major. One was an attorney that had a math major and then went to law school. And he said it was pretty funny sitting on the stand when somebody would try to get some physics past him, like in a car wreck, and he would go, no, that's not right. The wire would be going on and on they were used to being able to fool people with a lot of physics and math, or they didn't know what they were talking about and thought they could keep on moving, and he was like, that's not right. But anyway, from what I remember that the doctor said is that there's times that you've got to do bypass surgery, and if you know more about it, please jump in. There's times you have to do bypass surgery, and there's sometimes you can do like a stent or balloon treatment. Like, for instance, my father had heart trouble like his whole life. Well, I'm sorry, that's an exaggeration, from like 50s to 80s. So kind of at a relatively young age, I was like one with the dad that had a heart attack. And I remember at one point he had to have like triple bypass surgery. But I also had a friend that had a heart attack at kind of a young age, and they were able to put him in the hospital and do what's called a stent and force this like balloon to blow up make your artery expand so that the clots can get through, and then they put a stent in. So they balloon it up, and I'm doing a really bad job. I'm so glad. I mean, I hope nobody listens to this video because I was in on both decisions, like the doctor's telling me what's going to happen, but that's all I know. But the doctor that day in class was kind of saying, this is how we make the decision. So we got to know the rate of blood flow through the arteries before we make that decision. If the blood is still getting through the arteries, we've got time to do that balloon treatment, which is a lot less invasive, like you could go home the next day, as opposed to a slice you open and operate on your heart. So you'd like for them to understand the mathematics behind that. That's all I know about that. But there's something to do with the radius of your artery, and so we all have a different radius of our arteries. I don't know how they measure that, so I'm going to move on. But also, if there's blockage out to another radius, that's what they're looking at. Okay? So I'm pointing like fingers here, but y'all see what I mean? They're looking to see if it's one of these two things. So capital R is our capital R is the radius, and little r is how far it is out to where the blockage is, from what I understand. You may wonder why I let these problems go, like the ones that would have to be a whole lot more clarified before you put on the AP exam. I want you to really think on it. Don't let me just always bail you out and she's going to go through it. I want you to really, you're going to process and think through what's going to happen. Also, I think it's kind of interesting to talk about. All right, so let's talk about what the constants are here. So they gave us a similar formula. And it said the velocity of the flow of blood at a distance r from the central axis of an artery of radius r is V is equal to K times R minus R squared, I think is what that is. Yeah. All right, now I didn't have many people ask me this question, so my guess is you're looking at Slater and like really trying your homework, and you may have more that you've read about this. So, like I said, please jump in. That's the velocity of the blood flow that they're trying to see how fast it's getting through there to make a decision of what they're going to do to the patient. That makes sense? Okay. So the inner radius, in our problem, it says the artery has a radius. And they're trying to figure out the difference between that and the inner radius, which they didn't do a good job explaining. They're just assuming we know about this. All right, so it also says that K is a constant of proportionality, so treat K like a constant. Why are they not giving you any of these? It's because if I go into the hospital with this procedure, I don't know how they're going to find out. I have no idea, but they find out the radius of my artery, then they have a constant, and I have my own constant of proportionality, but it's constant for me. So it's not really a variable, if that makes sense, okay? So the only variable here is this. You see how that could change? In fact, my friend that had the balloon treatment and went home the next day actually had 99% blockage in one of his arteries. And another day or two that went by would have been disastrous. But I don't know how they decided to do the treatment that they did, but it was very successful. So, about the rate that the blood is flowing through the arteries, how can I find the blood flow? I know it says average blood flow, I'm going to get to that in a minute. how can I find the blood flow? The total amount of blood that's flowing through that artery. Well, you know what you're studying right now, but if I integrate velocity, if I integrate the rate of blood flow, wouldn't it take me back to the total blood flow?
Yeah.
Alright, so think of rate, I mean, I'm gonna get it out of blood flow because I don't know anything about it. If I'm driving a car at 50 miles an hour, and I total it up for a certain amount of hours, I find out how many miles I'm in. You see how you go backwards? So I'm gonna integrate this velocity. If I integrate velocity, you see it'll take me to total blood flow. Let's see why. If that's the velocity of blood flowing through the arteries over a given amount of time or a given radii, I think is really what's happening here. It's gonna you have velocity, and did they give us any kind of units to measure here? I have no idea what the units of measure are. But let's just go back to something that I do know. If I have something at feet per second for a number of seconds, underneath here, it's gonna be feet, the antiderivative. Alright, so I took the antiderivative of velocity. And I would have to admit, you have problems very similar to this on the AP exam. You've already seen me ask you some of those, like, what does this mean? But you have a lot more information about it. They would have to explain to you what's happening. Alright, so anyway, I'm gonna go ahead and work the problem. Because we do have to do things that are so similar to this. And I've told you as much as I understand about this problem. Alright, so they told me to integrate it from 0 to r. 0 being it's totally blocked, and r being it's totally clear. Do y'all see that? Okay, so the little inner radius can go anywhere from 0 to the outer radius. Is that okay? Alright, so now why did I factor out k? It's just a coefficient, and they said it's going to be a set number for an individual. So now I'm going to integrate this, but which one is my variable? The little r. So if little r is my variable, what is the antiderivative of r squared? Little r is my variable. So the antiderivative of that is going to be r cubed over 3. So some of y'all may were saying what happened to that, but I heard some differences. R squared, what? I can't hear you. Just say the whole thing. R squared. Okay. Thank you, Sophia. All right, let's look at what Sophia was saying. And yes, you do have to understand at least this part of it, okay? If I integrate a constant, you have a radius. If I integrate 4, and the antiderivative of that 4x plus c. All right, so if we don't know what r is, say if I knew r was 7. Now this is just the beginning of what I say follow your variable. Our variable right now is the change in radius. And so if I integrate 7 with a dr, it takes me back to 7r plus c. So do y'all see what Sophia's doing here? Treat it like a coefficient or like the antiderivative of a number. All right, now I'm going to fill in r. The big reason I wanted to do this problem is we'll do some more like it off of real APs, the ones that we can understand a little bit better. But the big deal here is just be literal and keep on moving. Because we tend to freeze up and just go, oh my gosh, I don't know what's happening. And I do know my next move would be to fill in r. If I fill in capital R for little r, I'm going to do top minus bottom. So that's going to give me r cubed minus r cubed over 3. Don't neglect filling in 0, but if I fill in 0 for little r, I get 0. But don't neglect filling it in. It's tempting. All right, so now I have k times r cubed minus r cubed over 3 gives me 2/3 r cubed, which is the total blood flow through the artery. Did y'all see you got a common denominator and subtract it? Okay, other homework questions?
Wait,
I
forgot to divide by r. The question was
Oh, thank you.
average.
I'm sorry, thank you so much, because that's where I need to go next in class after I finish homework questions. Thank you. And it didn't say the total blood flows through the artery, that's how much blood is flowing through that artery. Based on the rate of blood flowing through the artery. How would you find the average? Do you have a question or are you gonna answer?
No, it's a question on average.
Okay, hang on. I asked girls this morning in the math center, what I did the other day when I was, getting for one of my classes, I wanted the average test score, because a couple of people did really poorly on like an algebra 2 test I gave. And, I was thinking, well, gosh, there's something wrong here, so I wanted to get the class average, on the test, which I don't do a whole lot. But how would I get the class average? I would add up all those test scores and then divide by what? The number of test scores, right? All right, so this one's going from 0 to R. Like, imagine if I'm going from 0 to 8. Wouldn't I then divide by 8?
Yes.
If I'm going from 1 to 8, I would divide by 7 to get the average. So then I'm going to divide all of this for average, I'm going to divide it by R. Which gives me K times 2/3 R squared would be the average rate of flow. I'm sorry, the average, yeah, we're back to rate. By the way, we're back to rate. And I wish I knew my units of measure here. So I'll make it a better case for this later in problems that I understand better. I do this to myself every year. Around this funky problem. But I like that you have to deal with the variables in that manner. And I'll explain average a little bit better, but you see I just divided by the total? Okay. And when I've got some good handy units of measurement, I'll get better at it later today. Okay, any other questions on the homework? Grace?
66 actually.
All right, 66 is out. Okay, well, I'll answer that in just a minute, that's where we're at. Thank you. Anything else on the homework? Now check in your answers, look at Slater and
Yes.
Couch Chat.
Yes.
Oh, I need to tell y'all this if I haven't. It's like, about in February, I wanna warn you about this. I don't know what happens. It happened in the solution manual I have for the books, and it happens on Couch Chat. It's like all of a sudden some alien has landed in the Couch Chat, and they start doing things that aren't notations that we're used to, or even the way that I would work them. I still check my answers on Couch Chat, but if you see some things, you're like, what in the world is this? Just, ask me, you may have to ask me more questions. It's not gonna bail you out as much later on. I don't know why that is. But I find Couch Chat is always very useful for the answers, but maybe not for the solutions. So just be aware of it. Any other comments before I move on? Okay, so, y'all do this real quickly.
Can we read out the answers for 66?
I'll pull them up in just a minute. All right, I'll tell you what, somebody volunteer to read out their, I don't have my written down, Grace. Somebody volunteer to read out 66A through E, that's brave. And let's see if we all got the same, if we agree. All right, Anna, 66A.
Negative 1.5.
All right, B,
5.
5, C,
6.5.
D,
3.
and E.
15.5.
Okay, on D and E, so, do y'all all agree on that? I guess I can spot check them. If you have -2 on D, D is -2 f of x dx from 0 to 2. You can take out the -2, and then I guess you just multiplied by, what did they tell you in the original? They told you the area was 1.5, but since it's underneath, you had to use -1.5 for the actual answer to the interval. Because the interval just keeps it running total. So did y'all say -2 times -1.5? For D, okay. And then for E, I think you had 2 plus f of x dx. So hopefully you integrated that, you broke it up into two things. If you didn't, that's what you would need to do. And E is going from 0 to 6, which would really be displacement here. So this one, you would use the given information. This one would be 2x from 0 to 6. Okay? So this is real important. I don't want to see anybody miss that on the test. I want to make sure I make that really clear. Because some people don't find that real intuitive, just to break it up into two intervals. Okay, so I'm going to hand these to both edges, and I gave you the average value formula, which some of y'all have been asking for. And so I want you just to work 1 through 4 with your friend or by yourself, and then do 6 through 8 at the bottom. These are not difficult. You definitely can talk to each other, but I just want you to discover the average value for yourself before I show it to you. Talk to each other. I'm gonna run to the bathroom while y'all keep working.
Squared is 9, 9 divided by 3 is
Did you flip the
3 plus 9 is 12. When you plug in 0 and 0, and divide by 3, it's the average. 27.
Wait, you have a function and then
Yeah, yeah.
for this part? So you did the same thing. It's
Did you get 6?
So it's 2. Yeah, I got 6. I got a regular.
What is
Yeah, I got
1
6.
divided into 9 is 18.
Sine of pi over 3. Yeah, but it's negative. Why do you know it's not? It's not. Okay. Yeah.
Sine of pi over 2 is 1. 0.
Wait, what did y'all have to do?
2 over
3 is negative. Yeah. What's that by? 1, 0. Oh, that's the negative one. So yeah, what's sine of 1? Oh, but cosine of 0 is 1.
Cosine of pi is
Wait. It would be negative.
It's negative one, it's negative minus negative one. But what do you do with the one?
We got 2 over 5.
So is it 2? Is it 2 over 5? Okay. Yeah, that's a big question. 1 over.
It was good with the fractions. It was like, yeah.
Oh, wait.
No, for 4, 2 over 5.
Oh,
You're right. Okay, there's no right, girly.
We're graphing 1, 2, 3. So we graph the function, then we just draw the line.
Okay.
Which function? The x squared plus 3.
Yeah.
You can do it on, just a quick graph, a pretty decent one's all I need. You can do it on the back or something.
2 over 5. Yeah, oh my god.
Yeah.
Your answer that you got for number 1.
Oh,
Did you get 6? So just draw, and you do it from the limits of integration. Girls, the bottom part, like number 1, you should only graph it from 0 to 3, and then draw your y equals 6 across during that time frame. Stay within the limits of integration, like that. So follow your limits of integration. I'd go pretty fast and draw that horizontal line. You should have gotten a number for every other thing.
I did that.
Oh, yeah. Yeah. And then
Yeah.
Yeah.
So that's why it's probably 7.
Yeah.
Yes.
No problem.
Did you? What is the value? Because some starts at 1 and it's like 2/3. It's about 2/3, you know. And then it hits 0 at power 2. Wait, this doesn't look right. And then it hits 0 at no, it hits 0. No, it hits 0.
Yeah.
Are y'all doing cosine?
Okay, you just can't do this.
Are you doing it 0 to pi over 2?
You can't do basic.
Cosine of pi over 2 is 0, so it's just that first little thing. It's like the first quadrant, where cosine is positive. So it's that first little lump.
What is 2 over 5? 2/3?
Yeah, close enough to that. It's like, yeah. It's a bit.
Oh, yeah, yeah.
X plus 2. Okay, should be able to hit.
Horizontal line. Oh, 6.
And did y'all girls hear me say, stay within your limits of integration, Celine? Like 0 to 3, don't just draw a total.
No, I just want to say.
Okay.
So it's like this.
I think I draw this.
Line number 2 is.
Okay, no arrows. It only goes from the limits of integration. Even your lines. Even your line.
Oh, okay.
Your line only lasts
So do I listen to that?
during that time. Your line only lasts during that time.
I would have thought. We can understand that. Wait, this yours looks like that. What is, wait, stop. Sine of pi is 0.
Oh, I thought that was your.
I was like 2, 4, 6, 4.5.
I mean, that makes sense, the average for linear segment would be like x plus 2, that's just like kind of like.
We've discussed this like 5 times.
Should be half.
I'm just kidding, just what I get.
Oh, it's 49.
Almost 5.
Oh, yeah.
This is so
Oh, no, it's not, it's just like,
No,
it's about, it's like, you're just like,
it's like,
Value,
it's like
whack.
the middle value.
yeah.
6 is.
But like,
Yeah.
I guess
it's
it's
not
the
the
middle,
middle,
it's like
for
the.
here.
Did they have the adoption? Did it become that Friday after we had rejected?
Yeah.
Smaller values.
Like, that's what I was telling my mom. I was like, if it needs 6, I really couldn't. I think that Dr. Dean just had my mug all weekend with my pen in it. I'm so sorry. I think. I think Richard would forever make the decision. See where they are. What? Richard would forever regardless of what they say. Yeah, I'm gonna tell her. I'm not gonna wait till I get home. I can't open it. I said I'm gonna have to watch me do it. I'm gonna do it. It's almost 5. It's like 30.
Hey girls, on your pictures,
Check as soon as it
like this, from 0 to 3. What was 3 squared? 9? 1, 2. Was it x squared plus 3?
Yeah.
On your picture, I want you to drop on both endpoints of your line at the end of the limits of integration, drop lines down. Okay? And you might be able to answer the last question after you do that. So your second one should look like this. Cosine x from 0 to pi over 2. And I think you got 2 over pi, which is about 2/3. So you see I'm dropping lines down like that? Alana, question?
No, I think I just drew my graph, which is why.
I didn't give you much room. Or graph paper. Okay, let's go ahead and stop so we can use up the rest of the time for, I just want to know if anybody discovered what you're supposed to discover. Did everybody's first 2 look like this? What was your third equation?
Negative sine x. Negative sine.
Negative sine x?
It was sine.
No, sine x.
Your third
Yeah,
one?
you're right.
Sin x from 0 to pi?
Yes.
Alright. So, it went up to 1, and went out to pi, like that. And watch this. What number did you get? What was your answer to number 3?
Oh, it's 2 over 5.
Oh, for number, was this 2? I'm sorry.
2 and 3 were 2. Yeah, they were.
Okay.
Me and
Alright, everybody watching?
Yes.
2 over pi would be about up here, wouldn't it?
Yeah.
Alright, now Stan, I didn't want you just to stretch the line out though. I'm going to drop them down from the limits of integration from 0 to pi. Yours probably looks better than mine. Let me undo that there. 2/3 is probably actually a little bit lower. I think I went too high for you to really see what I wanted you to do. That's probably more like 2/3. And it lasts from 0 to pi. Okay? Does anybody know where this was headed? Can anybody answer the last question? What do you think average value means? By the way, what you did on 1 through 4, you were finding the average value. Like a couple of times you were asked that on your homework. Okay? So you know what we're finding, Rose? Looked like you were going to say something. I'm sorry, I don't want to put you on the spot. Anybody know? Somebody said it. Grace?
Would it be like, so if you were doing it using a rectangle, it's like what the height would be? So
I think she's saying it right.
So it's like the area divided by the, like the.
Okay, so I think this is what she's saying. This red area, girls, this red area from 0 to pi is going to be the same as what?
The area
Of that rectangle.
Exactly.
All right, and listen carefully these last few minutes. You know we've already learned the MVT, the mean value theorem, okay? The mean value theorem tells you that if the function is differentiable, that somewhere you actually achieve a derivative that gives you that crummy slope that I talk about with such disdain, okay? So the slope from endpoint to endpoint is pretty pitiful, but at least sometime in there it does achieve that average slope, okay? If you were a student applying to college from this classroom, you'd probably be really mad if we gave the average, grade point average of your class, because yours is probably a good bit higher than the average, and you worked hard for that. Do y'all see what I mean? But somebody in your class has that average. Maybe. That's a bad example because it's not continuous, but y'all get what I'm saying?
Yeah.
Okay. So some people actually call this the mean value theorem for integrals. There's a mean value theorem for derivatives, which is about the same slope. Because derivatives are all about slope, right? Rate of change. Okay. Some people call this the mean value theorem for integrals, but we just usually in here and in the AP program, a lot join the other people that just call it average value theorem. Aren't we just splitting hairs at that point? What does mean and average mean? Okay. But when I say AVT, average value theorem, I'm talking about integrals. When I say mean value theorem, I'm talking about derivatives. Okay. So, do y'all see this running total that the integral takes? What's really cool is the average value theorem tells you, what's the word value mean? I want to get the vocabulary down. The y. Okay? It gives you the y value over that domain. It gives you the exact area. Did y'all see it now if you didn't see it on your little paper? Okay? Alright, so does everybody see what would happen here? There would be this red. Sorry, that's not red. There would be this red that would be captured up in there. That would be the same as the blue. So it gives you an average Y value. Alright, now I always call this mashed potatoes. It reminds me of mashed potatoes.
So good.
Okay? So, especially these mashed potatoes. If I get a spoon and I start to mash down on that, what's going to happen? We give somebody a mound of mashed potatoes, but if I start mashing down on it, what's gonna happen? Want it spread out and fill in the area of a rectangular dish, okay? So, you know, if I was your mom at Thanksgiving and I gave you a rectangular dish and a mound of mashed potatoes, my children would not at all be surprised if I took a moment to go, that's like the average value theorem. Let's all get a spoon and let's mash on our mashed potatoes and see it fills up this rectangular dish.
Dr. D.
All right? Did y'all see what's happening?
Yes.
Okay? Let me show you a better example. And girls, I really need you to be quiet. Here's a good illustration of it. This is the average value theorem, but you need to be looking. Okay. Can y'all see what's happening? As I go to different limits of integration, I get a different value, I get a different output, I get a different y. But what's happening in the pink and the orange? They're the same area. And hopefully you can see that with mashed potatoes. Because if I start mashing on this with my spoon, isn't it going to morph into there? Okay? All right, so let's look at the formula and why that's happening. All right, so if I have the integrals from a to b of f of x dx, keep in mind that you're not finding area, you're finding displacement. But it'll still work. It doesn't matter if somebody even goes negative, it'll still work, okay? And I'll talk about that in just a minute. If I add all of that up and then divide by b minus a, y'all see how I'd be getting the average value? I'm adding up all the scores and then dividing by the total number of scores. Stay with me. If I find area, let's just talk quite literally about area. If I find area,
This is so clearly a class. Yes, it's only 11:30.
area is length times width of a rectangle. What if I divide by the width?
You get the lane.
I get the length. So y'all see what's happening? You're dividing it by that width, b minus a.
Yeah.
All right, what if I have feet per second and I divide it by something like 5 seconds? If I know how fast it went, and then for 5 seconds, and I divide it by 5 seconds, what is feet per second? If I divide it by 5 seconds, that's like multiplying by 1 over. Sorry. Why is that not working? That should cancel out.
Yeah, it does. No, it doesn't. You get seconds.
Oh, I'm sorry. That's because I did it wrong. Okay. An integral of velocity will give you something like your total feet. Girls, listen. If I integrate velocity from like 0 to 8 seconds, it'll give me the total feet I went in those 8 seconds. Then if I divide it by b minus a, now I'll go back to feet per second.
Yes.
Okay? Alright, so the big deal you need to know is this is your average value formula. If that's the average value, you can use the formula, but I hope you see it's common sense. And we'll talk more about it. Homework will not be if you looked at the syllabus. I mean, as far as I would like, ever. But I'll post your homework, something on average value. So you're using the formula over and over again. Bye, girls. You can throw those sheets of paper away. You don't need to save them.